Okay, so this is what we're gonna do. Just like I told you the other day, chapter 3, we are not going with what the WebAssign does. So I took away your WebAssign homework problems. So you only have to worry about this paper assignment, okay? Because I don't want to give you too much, I don't want to bombard it with too many assignments, so you cannot really practice and learn. So I only gave you so far 2 problems last Tuesday. I'm going to give you 2 more problems today. And each problem has like 16 steps that you need to do. You gotta find 16 different items that I asked you to find. So your exam will be just like that. What I'm gonna do today, that's what you're gonna see in your exam. So make sure that you understand this so you can do your assignments as you're supposed to, following the steps, and then do your work and following the steps. As I said before, yes, you can use your notebook. You get to use your note when you take your exam. So if you do your homework clean and neatly, then you can easily refer your homework to help you when you take your exam. All right. And again, we're gonna find 16 items. So chapter 3, we are not learning anything new in a way, because we are using what we learned from chapter 1 and chapter 2. So we're gonna find first derivative, we're gonna find the second derivative, and we're gonna find like intercept and domains and all that. But like intercepts and domains, we already learned from college algebra class or pre-calculus class. So I'm not really teaching, but I'm kind of reviewing with you. All right, first thing, let's find the domain, because that's what we said. We're gonna find a domain. So let's find the first question was, it says find the domain. Okay, so domain means I need to know what x can I use or which x can I not use. So since this function is a rational function, okay, so we always have to worry about the denominator. If our denominator goes to 0, they become undefined. So the first thing I need to do, set denominator equal to 0. Okay, so which means what? So x squared minus 4 equal to 0, then x squared equal to 4, x is equal to plus 2 and minus 2. So in other words, I cannot use these two x's. These two x's is the one that I cannot use. So you're gonna say, so domain will be all real number except x equal to 2, negative 2. Or you can say what? I can say negative infinity to negative 2 union with negative 2 with the 2 union with 2 is positive infinity. So either way is fine. Or okay, also you can say what? Or all real number, x cannot be 2 and x cannot be negative 2. So every one of them is fine. This is how you're gonna write down. So your answer, you can write down this, is it fine? You can write down like this, or you can write it this. So they're all fine. So that's your answer. So your domain is every real number except positive 2 and negative 2. Okay, next. Okay, number 2, what do we need to find? Number 2 is find the range. Okay, so looking at this, so they're asking what range can I not use? So pretty much, looking at this, I can see you can pretty much use all the numbers you can use. Okay, the horizontal asymptote. So I'm not gonna do range yet. So actually this order is not right. So I may give you different order with your homework. But anyway, you gotta find all this. But I'm gonna skip the range for now because I need to teach you how to find horizontal asymptote and vertical asymptote. By the way, we already found the vertical asymptote. The x, the denominator, this one right here, this is your vertical asymptote. When your denominator become a 0, such that that x make the equation of the denominator become a 0, that x is your vertical asymptote. All right, so when you find your domain, you actually also doing another part of this homework, which is finding a asymptote, vertical asymptote. So you just found also a vertical asymptote. The domain is all real number except x equal to -2 and x equal to +2. That x equal to +2 and x equal to -2 is your vertical asymptote. So this right here that you found is answer to number 5. So I already did number 5, vertical asymptote. All right. So I'm not gonna do range yet because I wanna find, good morning, I wanna find a horizontal asymptote. Okay, there's use that one to clean up. Will you clean up that, please? Okay. Thank you. All right, so I am not gonna find the range yet, but let me find horizontal asymptote first. The reason is if you find the horizontal asymptote, that will tell you which y you cannot use, okay? Yeah, thank you, Ethan. Stephanie is right here, thank you. Okay, so let's find a horizontal asymptote, okay? Look at the problem. So I'm gonna skip the number 2 for now. So I want to do, which is number 6. Okay, is everybody with me? So horizontal asymptote, I need to give you a short lesson. You may have forgot because this is also we cover in college algebra class, but don't worry about it. I'm gonna just review shortly. It's not that hard to do. Say, so if you have, say say y equal to, so ax to the n plus, say 1, 2, okay, so you have that. And then divided by another polynomial, I call it b1 x to the n plus b2 x to the n minus 1. Okay, I'm gonna call it m this case. Okay, so you have, excuse me, should it be? So you have, it's a fractional, okay? This is a rational function again. Let's say you have a rational function, okay? That case, you have 3 different choices. So don't worry about the rest of the things, only worry about the highest degree. In this case, this is the highest degree in the numerator. In denominator, that is the highest degree. Okay, so do not worry about this part. Only worry about this, the very leading term, the highest degree of that polynomial. All right, so we have 3 different cases you gotta worry about. First case, if n, m is the same, which means numerator degree is the same as denominator degree. If their degree is the same, then y, the horizontal asymptote, is equal to a over b. The coefficient of that the rational function is your horizontal asymptote. Okay, second case. If n is greater than m, which means your numerator power is bigger than denominator. That case, no horizontal asymptote. Because you will have a slant asymptote. In this case, but I'm not going to talk about the slant asymptote right now, so don't worry about it for now. So I just covered the second choice, second case, which is your numerator and your denominator the same power. That case, you don't have a horizontal asymptote. Now let's look at the third case. Third case, if n is less than m. Okay, which means the denominator has more power than the numerator. That case, y is equal to 0 is your horizontal asymptote. Okay, to find horizontal asymptote, you have three different cases. Your numerator power and denominator power is the same, then the coefficient, the leading coefficient is your horizontal asymptote. Y is equal to a over b. If your numerator power is bigger than your denominator power, you do not have a horizontal asymptote. You will have a slant. We're not going to talk about it for now. Next, if your denominator has more power than your numerator, in that case, y equal to 0 is your horizontal asymptote. So you have three different cases for horizontal asymptote. So now let's look at our case. What is ours? So let's expand this. So we have a 2x squared minus 18 over x squared minus 4, right? So what is our case? Is it first case or second case or third case? What is my leading coefficient? This is what I'm going to worry about one, isn't it, right? So looking at that, my A is 2, my B is what? 1, right? So what is my then? This is my case. That is a case, isn't it? So for our problem, so horizontal asymptote is y is equal to what? A over b, in this case 2 over 1, which is what? 2. So y equal to 2 is my asymptote. So which means I do not have a y equal to 2 as my value. So now because this, now I can do my range, okay? My range will be, so I can go back to my range part, number 2 part. Okay, so I will do my number 2. Okay, Ethan, clean that before you. So range. So range will be now, range means y values, right? So we just figured out that is your horizontal asymptote. That means I can use every y value except what? 2. So I can say all real number. My answer would be, so I have 3 different ways. Say all real number except what? Y equal to 2, or I can write it down as so I can write down or say, or all real number except y equal to 2, or I can write down what? Infinity to 2 union with what? 2 to positive infinity. So I can write down 3 different ways. So or any of this case is fine. You can write down any of this way. Okay, so probably the best thing is what? Find your asymptote first, and then you can do your domain and range. So I'll probably rearrange your problem such that it'll be easier on you. Because as you can see, if you find your asymptote, they will tell you which X you cannot use. Like a vertical asymptote will tell you which X you cannot use. Horizontal asymptote will tell you which one, which Y you cannot use. Okay, so that's what I'm gonna do. So so far we got domain, we got range, we got vertical asymptote, and then you got a horizontal asymptote. So I'm gonna now moving on to x-intercept. So remember your problem is 2x squared over 9. Okay, so now let's do the number 3. So we found 1, 2, 5, and 6. Okay, now we're gonna do 3. So I'm gonna rewrite my problem first. Y is equal to 2, x squared minus 9 over x squared minus 4. Okay, so to find intercept, so I'm looking for x-intercept. X-intercept means what? You have a number in x, the y has to be equal to what? 0. That's what x-intercept means. X-intercept means you're going through the x-axis, but the y value at x-axis is what? 0. So I know for sure x-intercept means the y value has to be equal to what? 0. So I'm gonna set this equation equal to 0 then. Okay, because I'm looking for x-intercept, that means I can set y equal to 0. So that means I'm gonna just solve this equation, just like we always do, just a simple algebra that I'm gonna do. 2x squared minus 9 over x squared minus 4 equal to 0. And then I will multiply each side by my denominator. So that and that cancel out. It's still equal to 0 because 0 times anything is 0. So that means I have 2x squared minus 9 equal to 0 divided by 2 divided by 2. Then x squared minus 9 equal to 0. So x squared equal to 9. That means x equal to what? Positive 3 or negative 3. So I have a 2 x-intercept. So your solution, so x-intercept, I have negative 3, 0, and what? 3, 0. Okay, just simply solve your equation and solve for x. That's just simply what you did. So to find x-intercept, you set y equal to 0 and solve for x. That x that you get, that is your x-intercept. So you have 2 x-intercept in this case, negative 3, 0 and 3, 0. Now let's looking for y-intercept. Again, you have the same problem. So y-intercept. What does a y-intercept means? You have a 0 in the x and you have some number in your y. So that's what I'm gonna do. Okay, remember that I'm gonna plug in x as a 0 on my equation. So look at this equation. We have equation is equal to 2x squared minus 9, everything over x squared minus 4. So I'll plug it in, it's 0, right? So that becomes a 0, that becomes a 0. Then I have y is equal to 2 times 0 minus 9, 0 minus 4, which is equal to negative 18 over negative 4, which is what? 9 over 2. Okay, so I have a 1 y-intercept. So my y-intercept just happened to be only 1, which is 0, 9 over 2. Okay, All right, so far so good? Everybody good? Okay, now, so I finished domain, I finished range, x-intercept, y-intercept, vertical asymptote, and horizontal asymptote. Now, symmetry. Number 7 is a symmetry. I'm not gonna do symmetry yet because I want to graph. When you graph, you know your symmetries right away. So next one is a end behavior, which we can talk about that. That means I will take a limit of this. So I can wait on that too. So let's do the ones we already know really well. So first one will be what? What's the next one? First derivative. Let's take a first derivative. That would be number 9. So y is equal to 2 x squared minus 9 over x squared minus 4. I told you can just rewrite it as 18 over x squared minus 4, right? So we need to do quotient rule, okay? We gotta take a quotient rule. So let's do that. So I'm gonna put that to be my f, that to be my g. So I will find f is equal to 2x squared minus 18, and f prime will be 4x. G is equal to x squared minus 4, and g prime is equal to what? 2x. So now I'm just gonna plug into my formula. So y prime is equal to g times f prime minus f times g prime, everything divided by what? G squared. So if I plug it in, my g is 2x, x squared minus 4, and f prime is 4x minus f is 2x squared minus 18. G prime is 2x, everything divided by g squared. So x squared minus 4 to the square. All right. We just need to simplify just a little bit. We don't have to do simplify a whole lot, just simplify just a little bit. All right, so we're gonna expand this, distribute it. You get a 4x to the third minus 16x minus 4x to the third plus 36x. Everything divided by x squared minus 4 to the square. I simply just distribute it, okay? 2 times 2 is 4, 18 times 2 is 36. Okay, 4 times 4 is 16. Now, can I combine anything? Yes. Looks like this and that cancel out. So my answer is just 36 minus 16 will be 20. 20x, everything over x squared minus 4 squared. So that's my y prime. So we got the y prime. So we find the first derivative. So first derivative will gives me what? My critical number, right? I can set this equal to critical number. So what's the critical number? So I'm gonna do 11. To find critical number, what do? Critical number means what? Y prime equal to 0, and then what do you do? Find the x, right? Or solve for x. So I'm gonna have y prime is equal to 20x, everything over x squared minus 4 to the square. I'm gonna set them equal to what? 0. Then we have 20x, everything over x squared minus 4 square equal to 0. And I'm gonna multiply each side by x squared minus 4 square. All right, but this just simply equal to 0 because 0 times anything is 0, and that cancel out. So we have 20x equal to 0, then x equal to what? Again, 0. So I have a critical number, which is x equal to 0. Okay, anybody have a question so far? Okay, now I need to find critical point. But we already know what critical point is then. Remember, we plug it in x equal to 0 to find the y-intercept. So this case happened to be my y-intercept is my what? Critical point, because I'm plugging x equal to 0. When x equal to 0 means that's a y-intercept, right? You're looking for y-intercept. So number 12, critical point. So I'm gonna, my y is equal to 2 times x squared minus 9, everything could x squared minus 4. I'll plug it in, x as what? 0. So I plug it as a 0, plug that into 0. So I have a 2 times negative 9, negative 4, which is the same as 9 over 2. So I have critical point, which is 0, 9 over 2. It happened to be same as what in this case? Y-intercept. It happened to be same because y-intercept means you plug in x equal to 0, right? So I don't have to put this. Actually, let me not even put it in here because it doesn't really matter. So we got the critical number, we got the critical point. So we got critical point, okay, but we don't know whether this critical point is maximum or minimum. So I need to do one more step to know whether this is a maximum or minimum. So what's my one more step I need to do? Take a what? Second derivative. So let's take a second derivative now. So I'm doing a number 10. So I will rearrange this homework problem for you so you know what to do first. So easier for you. So I'm gonna find the second derivative. So I know y prime is 20x everything over x squared minus 4 n squared. So I'm gonna do just like I did before. I still have to use my quotient rules. I'm gonna call that as my f. I'm gonna call this to be my g. So f is equal to 20x. So f prime is just 20. G is equal to x squared minus 4 to the square. So g prime will be equal to what? 2 times x squared minus 4 times 1 power, and then multiply of this, which is what? 2x. Okay, so I just use a chain rule this case. Okay, because your parentheses to the second power, which is more than 1 power, so you gotta use a chain rule. All right, so now I'm gonna plug it back into our formula for the quotient rule. Quotient rule is what? G times f prime minus f times g prime, everything over g squared. That's what I'm doing. So plug back in, my g is x squared minus 4 to the square. F prime is simply 20 minus f is 20x, and g prime is 2 times x squared minus 4 times 2x. Everything divided by g prime, g squared. So I will have a, right now I have a x squared minus 4. It'll be 4 power now, because 2 times 2 gives you a 4. So now I have a 4 power. Now we're gonna just simplify this and see anything that we can simplify. In this case, I like to bring it out, the common factor, which is x squared minus 4 and x squared minus 4. So I want to bring that in the front. So I have x squared minus 4 to be my common factor. And everything else, I will leave it in the So now this become 1 power. And I still have a 20 minus, I still have 20x, have 2, and then I have 2x. Because I'm taking out one of them. I took out the x squared minus 4 in the front. That's the common factor. Okay, everything divided by x squared minus 4 to the 4 power. All right, now I can simplify. So I can cancel this one out, and that become a 3 power. It used to be 4, now become a 3 because I took it out, okay? Almost done. So what problem is now, let's do the FOIL. So I have a 20 x squared minus 80 minus 20 times 2 is 40, 4 times 2 is what, 80? 80x squared, right? 20 times 2, 2 times 2, 4, 4 times 2, 80. So it'll be 80x squared. Everything over x squared minus 4 to the 3rd power. Okay, so I combine a little more. So 20 minus 80 gives me a negative 60. So I have a negative 60x squared minus 80, everything over x squared minus 4 to the 3rd power. So I got that. So that is my y prime. All right, is everybody with me now? So far, so good? Okay. Now, next one says, okay, it says find a second derivative in a critical number, critical point, inflection numbers. Okay, inflection number. Inflection number means you're setting what? Second derivative equal to 0 and solve for x. That's why inflection point. So I'm doing a number 14. Inflection number means you set second derivative equal to 5 and then what? R for x. That's what that means. Okay. So inflection number means you set second derivative equal to 0 and solve for x. The inflection point will help you whether your concavity, which means like this is a concave up and this is a concave down, right? So inflection point will tell you whether you're going to have, whether your concavity will change, which means whether you have a minimum to maximum, you will have that middle point. The turning point, okay, the turning point from minimum to positive, I mean the minimum to maximum, that, what do you call it? The turning point is called inflection point, okay? Inflection point is, you will know whether you will have a turning point. Your concavity will change from maximum to minimum, okay? So let's look at it. So I'm gonna see whether we're gonna have a concavities, okay? So we're gonna set second derivative. Excuse me, this would be a second derivative, right? I forgot to put the second derivative. So second derivative, I'm going to set them equal to 0, which is I'm going to set them equal to 0. All right. Now we're going to do just like we've been doing. We're going to multiply each side by our denominator. Okay, just simply multiply by your denominator so you can solve for x. So that means you're going to say that and that cancel out, and this is simply just a 0 again. So you have Negative 60x squared minus 80 is equal to 0. And you add, and you have negative 60x squared equal to positive 80 divided by negative 60. So you have x squared is equal to 80 over negative 60. Okay, so which means 4/3 of negative. So we cannot have a square to be a negative number. Okay, just look at this one. It's saying x squared equal to negative 4/3, which means x is equal to square root of negative 4/3 of a positive and negative. We're not looking at the imaginary numbers right now. Okay, we're only worrying about the real numbers. Okay, not the complex numbers, but the real numbers. So in this case, because this is what? Imaginary number or complex number, so we don't have inflection point, okay? So you're gonna say, no, that's right, no inflection point. Number, since x is what? Imaginary number. Okay, so now, how do you find your max or min? Let's review that again. Remember, what have we learned last week? We said if f prime is what? F double prime is 0, what do you have? We have a what? Minimum. And if y double prime is what? Less than 0, we have a what? Max. Okay. So if, then, if, then. Okay, so I'm gonna plug it into our y prime. Watch I'm doing it now, number 16. You know what max? I need to find that. Okay, so y double prime, and then I'm gonna plug it in. Oh, I don't have an inflection number, so I cannot plug it in. I will plug in what? My critical number, right? So I will plug in my critical number. So plug in critical number here. So which case I have y double prime over 2 and y double prime over which number? Negative 2. So that's what I'm gonna do. Because we have two critical numbers, positive 2 and negative 2. Okay, you plug in your critical number to your y double prime to figure out whether that critical point is your max or minimum. Okay, so what is my equation? That was negative 60 squared minus 80, everything over what? 4, the third power. So plug it in. So what do you get? So if you plug it in this as a 2 square, as a 2 square, so you have 2 square minus 2 square is what? 4? 4 minus 4? That will give you 0. So it's undefined. And same thing for here. So at this point, you cannot tell whether it will have maximum or minimum. So I'm gonna just draw. So at this point, it's what? Undefined. Does everybody see it? Look at the denominator. If you plug in 2 squared minus 4, what do you get? A 4 minus 4 give you what? 0, which is undefined. You cannot have a 0 in the denominator. Okay, so in your case, you have to say undefined. I don't know it's going to be max or minimum. So let's just see what's going on. So I'm going to what we know so far. Okay. I'm just drawing my graph, what we know. Starting with my intercept, we found the intercept layer 2. The intercept to be 2, 0, and negative 2, 0. And we also know that would be our what? What was the intercept? I forgot. What was our intercept? Why x-intercept? Oh, negative 3, 0, and 3, 0, excuse me. Negative 3, 0. Oh, I got it wrong. What's my critical number? X equals to 0, not 2 and 2. So excuse me, this problem right here is wrong, right? I need to erase this part. Sorry about that. My critical number is not 2 and negative 2. What's my critical number? 0. Sorry about that, class. I didn't look at my critical numbers correctly. So my critical number is 0. Sorry about that. Critical number is 0. So you plug in critical number to y double prime, which is 0. So negative 60 times 0 squared minus 80 divided by 0 squared minus 4 to the third power, which gives me negative 80 divided by negative 64, which is a positive number. So when y double prime is a positive number, do you have a max or do you have a min? Min, that's right. So we're gonna say if we have a minimum at where? Which is a 0. When you plug in 0, what do you get the y value at the time? What was the critical point? 9 over 2? Okay. So at 0, 9 over 2, which is my what? That is my critical point. So at critical point, you will have a minimum. Okay, so I'm gonna do whatever we know.
Miss Harris.
Yes.
So the critical point is supposed to be like, I mean, not a critical point. The minimum is supposed to be a point.
Yeah, minimum is a point. Minimum is a point, maximum is a point. Minimum and maximum is your critical point. Okay, the critical point is your minimum or maximum, but I don't know your critical point is either maximum or minimum. The way that you know is you take a second derivative and plug it in the critical number to your second derivative. If the second derivative, when you plug in your critical number to your second derivative, that give you positive, that is a minimum at that critical point. If the second derivative is a negative, and that critical point is your maximum. So critical point will either give you max or minimum, okay? So we're almost done. We're gonna do this one again tomorrow. So I'm just gonna do whatever we know. I know, I'm sorry? So I'm gonna do, I know my critical minimum is happening at where? 0, 9 over 2. So 9 over 2 is 4.5. So right here, it's gonna be my minimum. Okay, that'd be my minimum, which is 0, 9 over 2. What else do I know? My intercept is where? x-intercept is 3 comma 0, and then what, negative comma 0. That's my x-intercept. What else do I know? My horizontal asymptote is where? 0. So y equal to 0 is my horizontal asymptote. Okay, what else? I also know what? Vertical asymptote is where? But the horizontal asymptote is 2 what? Oh, 2. Oh my gosh, thank you, thank you, thank you. I'm not looking at the right again, isn't it? Thank you. By the way, you need to go back to your notebook. If you don't, you will make a mistake like I do. So that is my vertical asymptote. X equal to 2, and vertical asymptote, x equal to -2, and the horizontal asymptote is 2. Thank you, Stephanie. That will be my vertical asymptote, y equal to 2. And then, is that the only thing we found? Anything else we found? Is it good? Okay, so I can graph, roughly I can graph now. Since this has been minimum, so I have to go up. Okay, and everything else has to be what then? Come down this way. Okay, I need to come like this. Because I'm supposed to have x-intercept, so I need to pass this. But I cannot go above my horizontal asymptote. So this is what your graph looks like. Okay, so we're gonna finish this one again. I will go over this one more time. Okay, so I'm gonna stop right here. So yes, you can do your homework problem. So do your homework problem so you can ask me tomorrow. Be sure to do your homework problem so you can ask me tomorrow. Okay, your exam will be just like this. You gotta find all the steps. Okay, so make sure that you got your note so you know what to do. All right, okay. All right, you guys have a.
Did you want us to skip, I think it was number 7, like you did?
Sorry?
You skipped a number. I think it was number 7. Did you want us to skip that one too?
Number 7. Oh, symmetry. Is this a symmetric? What a symmetric means? When you fold it, okay, when you fold it, they're exactly the same. If I fold it by this line, which is what? X equal to 0. Can you fold it exactly same? Right? So your symmetry is where? Symmetry at x equal to 0. That's your symmetry. Just think about it. If I draw this line here, okay, and you fold it, when you fold it, they're exactly the same, isn't it? So there's symmetry at x equal to 0. Okay, so yes, number 7 is this. Symmetry at x equal to 0. Okay, and then can you tell me the end behavior? End behavior means, look at your graph. In this case, where does this go? If I put the limit, I can stop right now actually. So don't worry about end behavior. So you can skip number 8. You may skip number 8. Skip number 8. Okay? All right, do your homework problem, and I will see you tomorrow. You need to do this work again by yourself because we cover quite a few things today. All right, do this one again so you can ask me tomorrow.